The review today from Chapter 8 for Chemistry 2 is going to include molar mass and percent composition. So let's start with molar mass. Molar mass is a simple concept. Remember that molar mass is the mass in grams of 1 mole. So molar mass, by definition, is the mass in grams of 1 mole of the substance, and the information is from the periodic table. So just a couple of things that I want to remind you of. Remember that this comes from the atomic mass, so 14.01 grams per mole on the average of nitrogen, and that's strictly from the periodic chart. When we're doing a single element, that's where we get that. When we're doing a compound, we get the same information from the periodic table, but remember, if we have more than one atom of that particular element in the compound, we have to multiply that in. So for water, it's 2 times the mass of hydrogen plus the mass of oxygen. One that's a little bit more complicated looking is barium nitrate. So we have 1 barium, and that's where the 137.33 grams comes from. And remember that nitrate ion works just like it would if it were variables in algebra class. So we're going to multiply the subscript out here times the subscript inside, just like we would multiply superscript times a power. So 2 times 1 nitrogen is 2. That's where that one comes from. And then the 14.01 is the mass of nitrogen. Then 2 times 3 is 6. And that's where the 6 comes from. And then oxygen weighs 16 grams per mole. So when we multiply and add that together, we get 261.35 grams per mole. So we need to focus on how to do calculations using the molar mass. Remember that you have to be able to cancel your units, and this is the way the book shows you how to do it. Let's take a look at one of the examples here. Okay, so it wants to know what the molar mass of nickel 2 carbonate is. Well, first of all, you have to know what the formula of nickel 2 carbonate is, which causes you to rely on your ability to name. So nickel is Ni, and it's telling you have a +2 charge. That's what that Roman numeral is right there. Carbonate is CO3, and it has a -2 charge. So since our two ions have equal and opposite charges, it's going to just go together, NiCO3, with the overall charge of 0. So to find the molar mass of nickel 2 carbonate, you're going to write out each one of these. I'm going to go to the periodic table to find that information. So if I look up nickel on the periodic table, the mass is 58.69 grams per mole, and I only have one of those. Carbon on the periodic table is 12.01 grams per mole, and I have 3 oxygen, and oxygen is 16 grams per mole. So just to make sure that we follow the example out, some of this you can do in your calculator at this point once you've written out what each one of them are, so I'm not too concerned about that. So if we have 16 times 3 is 48, so we take 48 plus 12.01 plus 58.69, we end up with 118.70 grams per mole. So that's the mass of 1 mole of nickel 2 carbonate is 118. Okay, so let's take a look at this problem. It says how many grams of fluorine are contained in 1 molecule of boron trifluoride. So first of all, we have to have the formula for boron trifluoride. This is one of the easy ones because it's 2 nonmetals and they just use prefixes, so we know how many of each we have to have. And we have 1 molecule of boron trifluoride. So if we're going to look at it like this, it really kind of has this planar shape to it, and this is what we're looking at. So for every 1 boron, we have 3 fluorine atoms or ions connected to it. So 1 molecule of boron trifluoride has 3 atoms of fluorine. So what it wants to know is how many grams are in that 1 molecule, how many grams of fluorine. So if I have 3 fluorine atoms and I know that 1 mole has 6.022 times 10 to the 23rd atoms of anything in it. That gets rid of atoms, and I have moles. Then I want to know the mass because it asks for grams. And I look at the periodic table and I see that fluorine weighs about 19 grams per 1 mole. So my moles cancel out. So I take 3 divided by 6.022 to the 23rd times 19. And the answer that I get is going to be 9.465 times 10 to the negative 23rd grams, which is going to be. The second part of the lecture today is over section 8.6, which is percent composition of compounds. And this is one of the easiest things that we do in chemistry. Mass percent of an element, all you have to do is take the mass of the element in the compound divided by the total mass of the compound times 100. And the examples that we talked about last year were if you had a test and you made it 80% out of 100, what would be your percent? So the grade that you received over the total possible times 100 is how you figure your percentage on your test. And it's the same way we do mass percent of an element. So in this example, we see iron 3 oxide, and we want to know what is the mass percent of iron. So the first thing that you have to do is figure up the total mass, molar mass of Fe2O3. And they've done that here kind of shorthand, but it shows you that it's 159.7. And then you have to take the mass of iron out of that compound, which is 2 times the mass of iron because there are 2 of them. That's how much you have. That's on top. That's the mass of the element. You take those 2, divide them, and multiply by 100. So the mass percent of iron in iron 3 oxide is 69. Let's look at this last example of percent composition of compounds. So this exercise says that morphine, which is derived from opium plants, has potential for use and abuse, and its formula is C17H19NO3. So what percent by mass is the carbon in this compound? So the first thing that I've done is I have added up the molar mass of the compound. And if you notice, the systematic way that I did this is going to save time when it comes to doing the final answer for this one. So it wants to know just carbon, what the mass percent of carbon is. So we're going to take the total mass percent of carbon, which is 204.17, and we're going to divide it by the total mass, which is 285.19, and we're going to multiply that answer times 100. So we take 204.17 divided by 285.19, multiply that times 100, and my mass percent is 71.6% carbon, and that's your final answer for that.